Supply chain and check challenges are becoming more and more common attack vector. Only last week did Agama disclose that they were been vulnerable due to a compromised version of the Electron native Notify package that had gotten into their product. Other examples include Ticketmaster and a hack on the ASUS update service that started to push compromised versions of system updates to their laptop. Finding the cause. In each of these cases, someone managed to trick either the site or the build process of the site to download a dependency that allowed the attackers to compromise the rest of the solution. In our case, it's a NuGet package, and if all went well, you've already figured that one out. If you look at the change that was committed, even though it seems a bit haphazard, a simple text change in the website isn't the most likely cause of this problem. The package that causes this is a specially crafted NuGet package. We're using the name of an existing package with the vulnerability, but the version that we're using doesn't actually exist. The official NuGet Graal package only goes up to version 0.6.0, but we didn't want to inject an actual vulnerability in your website. This does allow you to detect it as if it were real. So let's look at some of the ways that you could have found this one out. One way is to use the Chrome Developer Console to see which scripts libraries are included in the JavaScript debugger and help you find out which ones are currently running. This will lead you to the first hint of the PU Analytics script. Another way to find this script is through comparing the contents of the current deployment package with the previous one. Apart from some binary differences, the sudden inclusion of the PU Analytics file stands out. We can actually dig into the build logs to see that MS-build copies that PU Analytics file. From there, you can dig into the build logs to see where that file is copied in by MS-build. The hacker was also nice enough to leave a big clue here, saying inserting payload. Any self-respecting hacker wouldn't mention this, but this was also a hint to drive you in the right direction. And part of the logs will also help you identify the NuGet package that was the source of this script. That was Graal 0.7.0. From here, things become fuzzy. Where did the package come from? The NuGet restore logs aren't entirely clear. None of these clearly show which dependency pulled in this package. You could trigger another build and attach the object/project.asset.json file, or you could locally restore the packages with the correct feed and use the .NuGet packages folder in your profile and search for Graal 0.7.0 to see which other packages references this package. As you can see, the partsunlimited.commonbase 1.0.24 seems to be the one that introduces this unexpected dependency. So, how did that get included? The Parts Unlimited package doesn't contain a strong version, so how does that get included? The Parts Unlimited package doesn't contain a strong version dependency on the common base package, and the NuGet resolved this version as it was the closest available. In our case, it was introduced by pointing to a different package feed. But this can be caused by a number of reasons. The blog post in the postmortem lists some of these. Closing the hole. To resolve these kinds of issues that stem from unexpected differences in the dependencies pulled down on your local development workstation and on the CI server at some later point, NuGet has introduced locked mode. This generates a file with the exact versions and the hash of the package contents that were used when you last pulled the new set of packages. By comparing this file whenever it changes, it gives you a list of dependencies that you may want to inspect a little bit more in the future before committing your code and pushing it to production. It also provides a bit of an audit trail to see which changes got introduced when and who were part of the review process. To generate a log file, first make sure you're running the same .NET Core version as the one referenced in the Azure Pipelines YAML file. Run .NET --version. It should return 2.2.106. Then run the following command to generate the log files. .NET restore -F for forced reevaluation, and then use log file, and then parse in the solution. This will generate the log files. Commit these files and then push them to the Git repository. This will allow the build server to verify it has pulled down the same packages that you have locally. It will even make sure that the contents of the packages are the same. You can also create a pull request and merge the vulnerable package/add log files NuGet branch to pull in the log files without having to generate them locally. You can add this command to the build.ps1 to make sure a local build updates the log files. Then proceed to the Azure Pipeline YAML file to tell Azure Pipelines to enforce log mode during restore. To do so, update the .NET Restore task and add --log mode --force evaluate. Commit these changes and trigger a new build. Commit these changes and trigger a new build. These builds will now fail, as the build server is looking at a different feed than you do, preventing this in the future. Let us add a way to detect these vulnerabilities even if they slip through the cracks. Tools like SNCC and White Source Bolt can help you detect vulnerabilities in your local workstation, as well as in Azure Pipelines. Edit the Azure Pipelines.yaml and add the SNCC2 task after .NET Restore has executed. Point it to the **/object/project asset JSON to detect issues in NuGet dependencies. Set test to true. Specify the service endpoint GDBC2019 SNCC, and tell SNCC to fail the build when issues are found. Commit the changes and queue a build. This should detect the vulnerable Graal 0.7.0 package and fail the build, even if you accidentally commit logged files that did reference this package. Get notifications. This is nice when a package has an already known vulnerability, but what if the problems are found after you've already published your website? SNCC has a second option called Monitor, which will send notifications for issues in your dependencies as soon as they're made known. Update the SNCC task and add Monitor True to receive such notifications. But of course, we don't want these kinds of notifications for just any branch out there. Those issues will be caught as part of a pull request to master or when that branch is updated. So we should limit Monitor to only be used when building from master, not part as a pull request, and certainly not for forked repositories. YAML has an extensive expression language that allows us to specify such conditions. Save the file and commit it. Not just NuGet, NPM has similar features. The same thing we did for NuGet, we should also do for NPM. The trick is remarkably similar. Clone the solution and then run npm install from the folder inside the website project. Run npm install . Commit the generated package logged file and push it to the server. You can also create a pull request and merge the vulnerable package add log file npm branch to pull in the log files without generating them locally. Now find where npm is called in the build process and change it to run npm CI on the build server instead. Now find where npm install is called in the build process and change it to run npm CI on the build server instead. Now find where npm install is called and change it to run npm CI on the build server instead. You can add the condition tf-build is true to the exec task, or you can move the npm CI step to the Azure Pipelines altogether, similar to how we did the .NET Restore step. And of course, SNCC also supports npm. To make SNCC detect the issues In the node modules as well, we need to update it to also look at for the package log files. And since the node modules folder can also contain these type of files, we should exclude those. It is possible that SNCC may detect issues that are found recently. If it does, you can either update these dependencies to a non-vulnerable version or add the vulnerability to the .snic policy files that you can find in source control. And that's it. The changes to the process will help you prevent unexpected package updates as part of the build process and add a bit of an audit trail to help you review changes that happen in the code that you don't own. SNCC will flag issues in packages you're already using and new ones that slip through manual inspection. It will even tell you when issues are introduced after code has been pushed to production. If you'd like to know more, read the links in the final postmortem step.